Hello again, and welcome to my last Measuring Time screencast. I'm Jose Rosa, science specialist at the Mason Pilot Elementary School in Roxbury. Now, I hope you've been keeping track of my backgrounds, the stuff that's behind me. Remember, I've been changing something about them. I have a common theme going among them, among all my screencasts, and I will be asking you a few questions to see if you've been paying attention. And the questions will be asked at the end of this screencast. Now, this screencast will go over lessons 13 through 16 of the STC Measuring Time Science Unit, all of which focus on clock escapements. Remember, your students should still be observing the moon phases and making recordings of their observations in their science notebooks as well. Now, during the next three lessons, students will focus on building a working clock escapement. Now, what's a clock escapement, you might ask? Well, let's watch a short YouTube video that explains it.
The anchor escapement can be said to be the heart of a clock. It is the source of the sound of the clock's ticking. The anchor escapement wheel would like to spin as it is pulled by the weight. However, the anchor horns alternate catching and releasing the escapement wheel as the pendulum swings, meting out the seconds. The pendulum continues to swing because the escapement wheel gives it pushes each time it is released. The push is enhanced by the clutch rod that acts as a lever arm. The illusion is that the pendulum is powering the escapement wheel and driving the clock, but it is the escapement wheel that powers the pendulum.
So, what did the lessons look like over the next three lessons? Well, students will construct the escapement beginning with lesson 13. They will adjust the escapement during lesson 14, just fine-tune it, troubleshoot it, and then they will calibrate their clocks during lesson 15. Now, students most likely have no idea what an escapement is. A video like the one we just saw goes a long way in helping students understand the purpose of a clock escapement. Now, after having a discussion about pendulums, students will follow the steps on pages 129 to 132 and to build the escapement. You can set up the distribution center like this one on the screen, and students can get materials as needed. Now, a few notes about this activity. This can be very challenging and very frustrating activity for students. It can prove difficult to build the escapements, and some students might feel like giving up. Try to give guidance as needed. In addition, I encourage you to build the escapement yourself prior to having the students build it themselves. Okay, let's briefly look over the steps. But before I do, I noticed that the directions look different depending on which teacher's edition you have. Just a quick side note, the teacher's edition that I have is this one. I'm not sure if you can see this clearly. And compared to another teacher's edition, the instructions were somewhat different. So the pictures that I'm showing in this screencast might not necessarily reflect the actual images on your teacher's guide. So this is how your escapement should finally look like. Like I said, some teachers' guides have a bottle with water. Other teachers' guides have washers. It all depends on which edition of the teacher's guide you happen to have. So as you can see, student instructions they're easy to follow, but they can get complicated as the students progress through the activity. You can see you start with the base, then with these rods, these posts, and so on. steps 7, 8, and 9. And then 10, 11. So this is what the final escapement should look like. And again, here's a picture of what the final escapement should look like. Missing from this picture is the C-clamp that is showing in this little picture that's over here. This holds it down to the table. Now, as a final activity, students can write a brief description in their notebooks about how they think the escapement works. Very abstract thing to ask them to do, but you can try it. Now, lesson 14 has students fine-tuning their escapements. It's a given that some escapements will not run. It happens every year. This lesson begins with a discussion on how the escapements can be tweaked so they can run. Remind students to change one thing, one variable at a time, to try to get their escapements to run properly. Now, there's a list of suggestions on what they can try on page 136. Once the escapements run successfully, students count the number of times the pendulum swings back and forth without stopping, and they measure how many seconds the escapement runs. This information will be needed for lesson 15, where students are challenged to invent ways to maximize the running time of the clock escapement. Now, to accomplish this, students will consider the following variables: the length of the pendulum, or position of the bob, the amount of weight used to turn the tooth wheel, the weight of the pendulum bob, or the length of the string used to turn the tooth wheel. Now, if they remember what they learned in previous lessons, they should know by now that the one thing that determines the frequency of a pendulum is the length of the pendulum. The weight of the bob has nothing to do with it, neither does the angle of the swing. Now, as students attempt to maximize the time that the escapement runs, they should record the results. They could use a simple T-chart like this one to make the recordings. Now, as a final activity, you can have a class discussion or have students report on their results to the rest of the class. The last lesson, lesson 16, provides students with a way to use all they have learned about variables to create a 1-minute timer. To accomplish this, students use the materials from the kit as well as any other materials that you deem appropriate. Now look at page 145 for a list of possible materials. After students have had plenty of time to build their 1-minute timers, have them compare the devices with each other. So that's it. We're done with the Measuring Time Science Kit. I'm sure I missed one thing or another, but remember to use the science department as a resource. They're always, always, always willing to help out. Okay, now before ending this screencast, remember my trivia question from my previous videos? It has something to do with my backgrounds. Did you notice something different on each one? Well, the action figures have been changing, but do you recognize any superhero teams? If not, here's a rundown of each one. By the way, the end of each screencast also has a picture of that particular screencast superhero team. So the first screencast was the Avengers. Did you get that one right? How about the second screencast? What was the superhero team in that one? Was the X-Men. The third screencast? Justice League. How about the fourth screencast? Well, this is a little-known superhero team called G-Force from the Battle of the Planet series that was way back in the 70s. Now, I had to go back way back to pull this one out. And how about for this fifth screencast? It was Guardians of the Galaxy. Awesome movie, by the way. And the last sixth screencast, which is the one we're viewing right now, it was the Defenders. And those are my action figures behind me representing the Defenders. Well, it's been great filming these screencasts. I hope you enjoyed them. But more